Hi everyone. Today we'll discuss one problem of boundary layer definition or equation. A boundary layer concept is very important in our day-to-day life. This is mainly used in aeroplanes. While designing aeroplane, boundary layer concept is a must. Otherwise, the plane may crash. So there is one question. Let's read the question. If a velocity distribution in a laminar boundary layer over a flat plate is assumed to be given by a second order polynomial u is equal to a plus by plus cy square, determine its form using necessary boundary conditions. See, boundary layer has some conditions, so we will use those conditions and find the value of this u. What is this u and y? U and y we know. Y is the distance from the plate. It is a plate. This is a plate and this is a boundary, and this is a fluid flowing towards the plate, and this capital U is the velocity of fluid, which is also called free stream velocity of fluid, and this small u or this u is the velocity within the boundary layer. Then this a, b, c are variable, and we have to find the value of u, b, c by using the different boundary condition. So let's solve. We know at y is equal to 0, u is also 0. See, when y is 0 means we have not moved any distance from this plate. We are here, and if according to the boundary layer, velocity just above the plate is 0, which is also called no slipping condition. So when at y is 0, when y is 0, u is also 0. So now substitute this value in the equation. U is equal to a plus by plus cy square. U is 0, a plus by is also 0 and is 0. Therefore a is equal to, we got a is equal to 0. Similarly, at y is equal to del. This del is a boundary layer thickness. Up to here the boundary will be, our boundary will be is given by d. So when y is d, the u will be capital U. See, when the fluid is within the boundary, velocity of u varies with the distance, with y. As you move away from this plate, and the velocity of u will increase, and when you cross the boundary, the u is equal to the capital U, which means at this point the velocity, this u is 99% of capital U. When it suddenly reach the boundary layer, the capital U, small u become capital U. So at when y is equal to d, when y is d, at here the u is 99% of u, means just suppose the u is equal to u, because you can say they not so difference between u and capital U. So u is equal to u. Now substitute this value in equation. Substitute this value here in the equation. When u is capital U, a we only got 0, and b, y is equal to d, and c, this is d square. From here you will get bd plus cd square. Del, this is del, actually this is del, not d. That is equation 1. Similarly, at y is equal to del, when y is the d del, when this y is del, I mean this the thickness of boundary layer and y distance from the plate is equal, there is also another condition, and that is du by dy is equal to 0. Now let's understand why it happens. See, this du by dy is a velocity gradient, which means the velocity increases according to distance. Where distance increases from the y, velocity also increases. It means the velocity is dependent upon the distance within a boundary layer. But when this distance is d here is equal to d, the velocity does not depend upon distance now. Above this, velocity is always equal to u, that is a free stream velocity. So that we can write velocity gradient at y is equal to d, velocity gradient is 0. Or now substitute the value of u from the equation, that is a plus by plus cy square by dy is equal to 0. So solving this derivative, you get this 0, this will get b by to cy is equal to 0, or this will be plus 2cy is equal to d, so 0. This is equation second. Now substitute s u b s t I t, substituting the value of b, that is minus 2cd, from equation 2 to 1. What we get when substitute u is equal to minus 2cd square plus c d square, that is minus c d square. Will the final expression when you substitute those value. From here, what we get, c is equal to minus u by del square. This will solve this, take that del square that side, and then we will get the value of c is minus u d square. Therefore, what is the value of b? The value of b is minus 2cd, and c already we have got as minus u by del square, and this d, this minus will become plus, d will go, it will become not 2e by d. Hence yes, we be as t substituting the value of a, b, c in equation, we get u is equal to 2 u by d y minus u del square y square. If you take u common on both sides, bring this side, it will be 2 y by del minus y square by d square, which is our final expression. So this is how we find the velocity form using different boundary layer condition.